What are the challenges of disposing nuclear energy waste? Imagine having to keep something dangerous safe for thousands of years, longer than many civilizations have existed. That's exactly what disposing of nuclear energy waste involves. It's not just about throwing it away. It's about making sure it doesn't harm anyone or anything for a very long time. Nuclear waste is made from materials that emit harmful radiation, and some of it stays hazardous for hundreds of thousands of years. This means we need disposal methods that can contain this danger over such vast periods. High-level waste, like used nuclear fuel, produces heat because of radioactive decay, which adds to the challenge. We have to cool it down carefully so it doesn't damage containment systems. One big challenge is ensuring the waste stays isolated from the environment. We want to prevent radiation from reaching people, animals, plants, or groundwater. Deep underground storage in stable rock formations is seen as the best option. But the problem is, we cannot be sure these underground formations will stay stable for thousands of years. Earthquakes, chemical changes, or natural shifts could compromise the barriers we build. To contain the waste, it must be sealed in corrosion-resistant containers, often made of metals or ceramics, and surrounded by materials like bentonite clay to prevent water from moving in. Designing these multi-layered barriers to last thousands of years is a complex task. Managing the heat generated by radioactive decay is another challenge. The waste produces heat that must be dissipated safely. If the heat isn't managed well, it could damage the containers or cause cracks in the surrounding rock, risking the releases of radioactivity. Although the amount of waste is relatively small compared to other industrial waste, its high radioactivity makes handling and storage very demanding. Public opinion and politics also play a big role. Communities often oppose waste disposal sites because they fear accidents or environmental damage. Building a deep geological repository takes decades and costs billions of dollars. For example, the United States' Yucca Mountain project faced strong opposition and was halted, despite technical progress. Reprocessing waste to recover usable materials can reduce the volume but raises concerns about nuclear proliferation, because separated plutonium can be used for weapons. This adds security and regulatory hurdles. No country has yet created a fully proven permanent disposal site that can last for the necessary time. Finland's Onkalo repository is the closest, aiming to safely store waste for at least 100,000 years. But such projects are new and carry many uncertainties. In terms of heat transfer, managing the decay heat is vital. It influences how we design storage containers and geological barriers. Proper heat dissipation prevents damage and helps keep the waste contained. Overall, the challenge lies in safely isolating highly radioactive materials that remain dangerous for thousands of years, while balancing technical, environmental, social, and political factors. The goal is to protect current and future generations from the harmful effects of heat and radiation from nuclear waste.